Hello there. Today I found an interesting number theory problem and solved it. And I'm going to show you the solution because it is very interesting as I wish. Well, what is problem? 1 factorial times 2 factorial times 3 factorial up to 100 factorial over x factorial is a perfect square, where x is between 1 and 100. What is x? Well, this sounds very interesting. For example, let's note, for example, what? Um, Everywhere here, we can rewrite it as a product of prime numbers. Prime numbers from 2 up to 97. But there will be some another, not like product of all them, one after another. 2 will be many times, 97 will be near 4 times only. Let's try to figure it out. Here I wrote all the prime numbers from 2 up to 97. Yes, so let's try to get 97. 97. We can make it only in numbers bigger or equal to 97 than factorial. Because if number is less, it will not have this prime number. For example, 96 factorial has not 97. It means it will be repeated only 4 times. 4 times is a very good number. Why? What have you heard about square roots of natural numbers? A square root of a natural number is very distinct stuff. For example, if it is everywhere I will write the prime numbers 3 times 3 times 3 times 3 times 3 times 2 times 2. Twice each prime number will give us its once. For example, it will be 2 times 3 times 3 times square root of 3. But square root of prime number is not natural number. It is irrational number, which is not natural. It means every prime number is to be repeated even times. For example, here it is 4 and 1. 5 is not. Let's just cancel. Now it is a perfect square of 3 times 3 times 2. Yes. That is we are going to get 2. Well, let's go ahead to our product of factorials. Let's now interesting thing. If you get here odd number, it will be repeated even times. Why? Because the way between 100 and 97 is 4. It is 100 minus 97 plus 1, because we will calculate this number. I will write it. The way between n and 100 exists 100 minus n plus 1 numbers, because 100 minus 1 is all the numbers we will get. For example, here 89 and sorry, all this 2. That means so I will try to calculate 2 plus 1. Well, if our n was odd, our sum will be even. And again, if it will be even, it will be odd. Okay, it means if it is odd for 97 and all them, we can just cancel them, because they will not change our product. Not so easily. For example, number 11 can be written as 22. 11 times 2 is 22. But its way is odd. It means we cannot say just simply 11 doesn't change our product. Square rules. Nope, it can. Bigger than 50, we will cancel it. I will do. I did. Well, what is about 47? For example, let's try to multiply it by some numbers. And what have we got? 47 can be written as 47, or 47 times 2 is 94, which is even number. It means 47 will change our product row of squares. It means it is to be cancelled to odd times once or 3 times, but it is to be cancelled. Well, it is, but so much numbers. Maybe we'll try something another way. Yes, I got it. It's a very interesting way. What have you heard about 100 over something? 100 over 2 is 50. That's why all the numbers from here will have factor only 1. Here they will get factor 2. And From here they'll get factor 4. Somewhere here will be appeared factor 3, but it doesn't mean a thing because 3 is not even number. It will not change our product, but even numbers will. That's why let's try to get here all the even numbers 2, 4, and there will change our cancelling line color. For example, here from 29 up to 47 will be boxed. It means they are imposters. They are imposters. Well, what's next? 100 over 10 is very close, but is there something another way? Because there are less numbers than we'll try to figure out. First, let's write what can we do. From here, we will again cancel it, and 13 will not be cancelled. Rewriting and magic. Only a few numbers are before. Let's just try them. Let's try them one after another. I will clear everything here. Well, now we got all them. For example, 11 times 9 is less than 100, but 11 times 10 is bigger than 100. Yes. From 1 up to 9, all the even numbers are 2, 4, 6, and 8. They are even times. It means their odd part will be repeated even times, and it will give us right nothing. Right nothing. I don't write nothing. For 7 it will be 14. 14 is 2, 4, 6, 8, 10, 12, and 14. Let's do the same stuff. You think we did everything correctly? Do you really think it? Yes, 2 and 13 are numbers to be changed, but 7, is it? 7 square is less than 100. We told 7 times 2 times from 1 up to 7 changed our rules at 1, and finally it will change it other times. It means it will change our rule, but wait, 7 times 7 never change our rule because it's even number. 7 and 7 twice. 7 times everything will be even. It will not change our number, but it from 1 up to 6. It will not change our number too. It means 7 was imposter. Now we got all them, but wait. 13 squared is bigger than 100, that's why we will not change it. But 2, what about 2? Well, we wrote to 2 times all the even parts from 1 up to 25, because 2 times 25 is 100, right? As I said before, we will accentuate all the positions of 2, that's why only even. 2 times 2, only 2. Time everything from 26, it will be bigger than 100, that's why we will calculate it. Well, from 2 up to 24 even numbers, it is 2 times, if you will change it, 12. Is this number even? It is even. It will not change like nothing, it will change like nothing. It means as it was, as it will be. It isn't imposter. You would like to relate all the real numbers other the times. But for example, 47 can be repeated in 94 and up to. It means if you would like to remove it, we would like to remove a number from 37 up to 93, one before, right? Because if it was 94 or something bigger, we will divide it 2 times. 47 factor and factor 94. It means our rule will be broken and it will be the answer. Well, it is between 47 and 93. The same stuff goes here, but here, from 13 up to 26. Yes? Bigger, it will be even times, and from 39 up to -1 from all the tails. Well, the other solution here is if you try to multiply them logically. Yes, logically. We will get from 47 up to 51, non-tangent 52, right? And wait, if you got about 2, it is green number 2. Let's try to divide those numbers from 37, 38, 39, and 50 times 2. And what have we got? If you'll take floor function from all these numbers, we'll get only 47 and 50 and 51. But wait, 51 is cancelled here. It means it is not being changed. But here it will be changed once, other times. This it isn't the answer. The answer is 37 or 15. But what is it? What is it? Almost forgot about 23, 19, 17, 11, 7, 5, and 3, which are red numbers. They are not being changed in our rule. It means 23 times what? Well, firstly, let's try to take 23 number. It is this what? It is even times. Algebra means cancel it. It isn't. Our checker 19 is the same stuff. 17, 11. Wait, 7. 7, as we told, it is imposter. It is red. It is wow, very interesting. Very interesting. 1, 2, 3, 4, 5, 6, and 7. It is joy. It is not. It is nothing. Because 49 is 7 times 7. We forgot about this, right? We forgot about this. Yeah, we forgot. We forgot about this. We made it graph. Yes. It changes nothing. Nothing. It means 7 is not checker though. Yes? It is not. Because everything here is even. It is always even and depends of this stuff. And it is bigger. It means 5 and 3. There are 5. What have you seen? Oh, okay, got it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. But here it is 9. Means in any way 47 isn't the answer, but 50 can be an answer. But wait, what would say 2? What 2? Sorry, 3. 3. I'm sorry. 50 over 3 is 16.6 if I remember. It means it repeats even times. Yes. 3 told nothing 2. It means 50 is the answer. Well, let's try to make a program to analyze this. As you can see, I will simply program to check out is this number being changed or it isn't being changed. Also prime numbers. I'm sorry for not prime numbers, but nothing happens. As you can see here, it is for x equals nothing, or x equals 1. That's why let's try to check for all the x from 1 up to 100. And if all them will be x, it means non-changeable, non-changing. Program will write as it is a solution. And it finishes its calculations. Yes, 50. It is the answer. Amazing. Well, as you can see, we solved this interesting problem. Yes, and got one interesting answer, which is 100. Well, goodbye, subscribe to the channel, type a commentary, like this video. Goodbye.